Now look at number 6 from fluids at rest. And in this one, it says you have plastic foam that is 0.1 times as dense as water. So it talks to you about the density. First thing to note is at the top of the paper, the density of water is given as 1,000 kilograms per meter cubed. Now, if the foam, density of that foam equals 0.1 times water, that means you get 0.1 times 1,000. That will give you a density of 100 kilograms per meter cubed. This says, what weight of bricks could you stack on top of the foam? So it wants to know, what is the weight of bricks that you could stack on top of the foam so that the slab of foam floats in the water and is barely submerged, leaving the bricks dry. So the weight here is you actually have the weight of the bricks, but you also have the weight of the foam. Now, in order for something to float, it's going to have to be in equilibrium. So you're going to have a counterforce here. And that counterforce is actually the buoyancy force, which is created by the displacement of the water by the foam. So in this case, what I need is that the buoyancy force, in order for this to be in equilibrium, F sub B is going to be equal to F sub G of the foam plus F sub G of the bricks. So if I'm going to find out how many bricks, or what's the weight of the bricks I can put on this foam with only having the foam barely submerged, that's what I'm looking for, is that weight. So the first thing I want to do is figure out what is F sub G of the foam. Well, I'll tell you what, in most cases we've used F sub G equals mass times gravity. All right? But we're not given the mass, we're actually given the density in this case. Now we are given a volume as well, and the volume is going to be equal to 1 meter times 1 meter times 0.1 meters, which is going to be 0.10 meters cubed. All right, so that's the volume. So given this volume and the density, we can use the formula for density. Remember, density equals mass over volume. So that means mass is equal to density times volume. So in this case here, my F sub G of the foam, I'm going to rewrite it. Instead of mass, I'm going to use density times volume times gravity. And this density here is the density of the foam. So this is just going to be 100, and that's kilograms per meter cubed, times my volume, which is going to be 0.1, that's meters cubed, times gravity, which is 9.8 meters per second squared. And that gives me 100 times 0.1 is 10. This would give me 98 newtons. Now, that gives me the foam. I can also find the buoyancy force. Because remember, for the buoyancy force, that buoyancy force is going to be equal to the density times the volume times the gravity, and that is of the fluid. which in this case is water. So finding that buoyancy force, finding the force of the fluid displaced, density of the water is 1,000, and that's kilograms per meter cubed, times the 0.1, which is the volume, times 9.8 meters per second squared, and that gives me 980 newtons. So now going back to this formula, we can figure out my buoyancy force is 980 newtons. And that's going to be equal to F sub g of the foam, which is 98, plus F sub g of the bricks. So now I subtract 98 from both sides, and I get F sub g of the bricks. In other words, the weight of bricks you can put on this foam, so that's completely submerged, but just to the top of the foam here, is going to be 980 minus 98. This will be 882 newtons. Please remember sig figs, this will be 880 newtons.